Welcome. This is the second August 2024 meeting of the Garden State Java User Group. Thank you. We usually,
Nice.
we usually have no meetings in August, except for one very special meeting where Mike Redlick spoke a couple of years ago with some interesting consequences. But this month we have two, and this is our second, of course, and our speaker today, Rustam Mehmandarov.
Yeah, perfect.
Thank you. I pronounced it's an F sound at the end, right? Instead of a B.
That's very nice.
I gotta thank you.
Nice.
Yes.
Nice.
And Java champion, Google developer expert on cloud. Excellent. And he's going to talk about Java on the Google Cloud, the enterprise, the serverless, and the native.
Thank you.
Rustam, take it away.
Thank you. It was a very, very bad attempt on the good, the ugly, and that thing. But so I want to talk a little bit about how things work on a cloud. And while I am talking, I have to multitask as well because I need to do some Zoom magic, I think. Let's see.
You're gonna go to
here.
here, right?
Yep.
There you go.
And
Excellent.
it's all good. Yeah, I need to remove this thing, right?
Yeah, there's a minimize button, little dash at the top, upper left.
No, it's actually on your screen.
Oh, well, then I'll get it.
That's on yours, not mine.
We didn't want that little thing.
Okay. Yeah, good.
And I guess I'll leave that up there. That's not hurting him. Right?
Yep. It's fine.
Yeah.
Right. All right. Okay. Now, it even possibly works. Yes, it does. Okay. So, I would like to talk to you about running Java in the cloud, and it does say Google Cloud Next. It does say a lot of Google Cloud all around. That's because I did this talk at Google Cloud Next a few months ago in Vegas. And this is a bit more a deep dive version of that talk. This is probably the only slide that will say all that. All the other ones are not. Most of the things I'll be saying and talking about is actually applicable for any kind of cloud or not even cloud. It can be on-prem as well. So you don't have to think about that. I will skip introduction of myself because Barry did an amazing job. I am based in Oslo, Norway, so I'm a bit far from home. But I'm on my vacation on the US for 3 weeks, roughly 2.5 weeks, and this is things you do on vacation. You come to Jugs and say hi and ask and say yes when opportunities arise. The host is muted you. Okay, it's gone. Okay.
Don't worry about it.
All right. I got muted. So what I would like to talk to you about is first of all, I want to talk about the options generally running it on a cloud. I will use examples from Google Cloud, but like I said, it can be any other cloud as well. If you want to use it on other cloud providers, you will find similar solutions to what I'll be mentioning as well. So don't worry about that. I will talk about what modern and enterprise Java actually means, like what is, because we talk a lot about app mod and application modernization, things like that. I will explain a little bit what that is, and this thing about serverless. I'm not going to talk that much what it means because most of us know now what it actually means, but I'll say what it usually brings to the table or what you need to think about when you go serverless. So, and that's where the optimization part comes in as well. So I'll be talking about ways to optimize your application and why do you need to optimize that as well. And some conclusion and stuff at the end as well. So what are actually the options to run that? Well, normally you have, so this is, like I said, examples from Google Cloud, but it can be Azure, AWS, or anything like that. Typically, you would go with something either going basically where you use some compute, you're renting CPU and RAM and memory, and then you run it. It can be things like virtual machines, which I kind of put into the box of compute engine, which technically that's what it is. Think of it as just virtual machines. And then you can also do Kubernetes clusters, cloud specific, or your own cloud Kubernetes clusters or anything like that. Again, it's still virtual machines running in nodes and everything, and all the way down, it's still virtual machines, and it's still compute and CPU that you're renting. And then there is another box called serverless. And serverless can come in different flavors. There are a bunch of, most of the cloud providers would have some kind of way of providing functions. So cloud functions in this case, it's called Lambdas in AWS. It's called something functions in Azure as well. So there's ways of running your code, your Java applications there as well. But usually it would be tiny little snippets of Java code. You can't really put a full scale, or you shouldn't put like full-fledged scale application onto cloud functions, because typically they won't be able to have persistency, or they will be limited with libraries. There are some things that doesn't work really well. Cloud functions is very good for very small pieces of code, and you can run that on Java code as well. It doesn't have to be Node or Python or Go or anything else. Now we're getting a bit closer to an interesting part that is, well, actually, let's talk about Cloud App Engine first before we talk about CloudRun. App Engine is, to me, I don't know how it is. I don't know if it's really a right thing to say, but to me, it's kind of the thing that started back in the days, clouds or whatever a cloud became later. That was the first way of running your applications in a tiny little containerized applications back in days before even we called it for cloud. But again, limited ways, some limitations are applied there as well, because yes, you can write your Java applications to run on that. You still might be limited with some libraries that you can use, way you can interact with your applications, ports, maybe things like times to live for your application. So your application might get killed without any control or things like that, and all that. I mean, all of those different ways of running it are totally legitimate and useful and very good ways for a specific user case. I would like to talk about a bit more about more generic and a bit larger Java applications and how to run them on the cloud as well. So that's where the CloudRun comes in. And CloudRun is actually, so it's a managed version and slightly modified version of Knative. If any of you know anyone, Knative?
Knative, yeah.
Yes. So good. So at least one hand goes up. But
understand your accent.
sorry, yeah.
It's Kanita. What's Kanita?
Knative. But yeah, so for those of you who don't know what it is, it's you take Kubernetes, you put some service mesh on top of that. It used to be Istio, now it can be other things as well. And then on top of that, you have a Knative running, which is a serverless offering that is an open source product that has been developed by several companies. So one of them was Google. I think Red Hat was there, and there are a bunch of others that kind of came together and defined that thing. So the managed version of that is CloudRun. I'll explain a bit more in a bit as well what it is and what it does, but it's basically I always say there is no such thing as serverless as like without servers, but it is managed less. So you don't have to think about management that much, and that's where that thing comes in. Why do we want to focus on that particular? So CloudRun or Knative? Now I have to like be very Knative.
You say it very well when you say it slowly.
I talk too fast. So one of the things is that it's everything, whatever you put into that little thing, it gets containerized. So it's a regular, plain, good old container where you don't really have to think about anything. It's just, you can take that container, put it in Kubernetes, put it on Knative, put it in CloudRun, it will still run without almost or zero modifications. With zero modifications or with, yeah, you get my point. Another thing is that it gives you, and well, since it's a containerized application, you can put it as a regular container. It also gives you a lot of flexibility. So you can choose runtimes you want. You can go with really anything. Like if you go with not even Java, you can pick a weirdest, most specific, strangest language you want, and you can still be able to run it inside a container. It's fine, just do it. And as long as it can receive HTTP requests and response with something, it will be fine. So that's really nice. When it comes to Java, well, you can pick and choose runtimes. You know, some of us are still running on Java 8, 6, something like that. Probably not a good idea. Probably you should upgrade, but you know, if it can be containerized, technically can run it. There is security, a bunch of security issues, but we're not going to talk about that for now. And it gives you a lot of portability as well. So you can, again, you can move it from CloudRun. If you don't want to run it there, you can move it to Knative. If you don't want to do that, you can move it to Kubernetes. If you don't want to do that, you can run it on anything, Docker, whatever you want to run on your laptop as well. Right. So that modern thing, an enterprise thing, when it comes to Java, what does that mean? Well, there are different ways of creating those cloud native applications. Usually if I get to choose, I stick with those two. So Jakarta EE, that is new. Well, it's not that new anymore, but still a new name for Java EE, J2EE, and all the other friends. That what it used to be called back in the days, and now it's called Jakarta EE. There is a little add-on on top of that, which is the micro profile that adds some more features for your microservices that can give you some more like things like health and bunch of things that like fault tolerance, resilience, you know, all these kind of things that it brings to your applications pretty much out of the box. It doesn't have to be that stack. It can be, call it Spring Boot. You can call it, you can use Micronaut. You can use a bunch of other things. I had to choose something, so I ended up with that. How many of you know Jakarta EE well enough to skip this slide?
I heard about it.
You heard about it. Okay, good. So then I'll go quickly through that slide. So Jakarta EE is a lot of it's a lot of different libraries. It's a bunch of things that build on top of regular kind of JVM or Java platform, and it has a lot of things that help you with making your both development and your applications a bit more smooth ride. So it's split in 3 different ways, so in 3 different groups. There is a core profile, which is the kind of the most core part of it. It has things like dependency injection. It has things like RESTful web services and all the other things. So that's the typical things that really our web microservices and web applications would really, really need. There is a bigger set of libraries that is called web profile, which has a lot of other things that we probably not gonna need, but we can import if we have to, for our use case. Things like WebSockets, what is there, servlets, and all the other things, concurrency. There's a lot of things, and they're grayed out for a reason, because we don't really need to think about them for now. And then there is an even larger group and kind of the full umbrella of Jakarta EE 10 platform that has even more stuff. But like I said, we don't really need to think about all the other things. That's the ones that our core profile is an important part, because I'll explain why in the next slide. What is important to note here before I do that is that all of that is specifications. They're all specifications and not really implementations, up to vendors to actually implement it and say that they're compatible. Jakarta 11 is just around the corner, so it should be coming out very, very soon. But for now, we're sticking with 10. Right. Core profile, right? That's why it's important. Well, because we're going to use that in a second, and that's where it is. So all that you saw in the core profile ended up that little box there. It's dark blue on my screen. It's kind of very dark on that screen, but that box there. On top of that, like I said, there are a bunch of things that microprofile brings to your applications, and that's what I usually call a modern. And modern, I usually mean cloud native applications. So, and what does that really mean? That usually means that it doesn't have to run on the cloud, but it should be able to. And to be able to run on the clouds, there's a lot of things like automation, and there's a lot of health checks, and automatic restarts, and scaling up, scaling down. There's a lot of things that really need to be in place to be able to be managed, for your application to be able to be managed by a cloud provider, or things like Kubernetes or something like that. To do that, we need to be able to expose that information. So we need some information about health. We need some information about metrics. We need some fault tolerance, because now everything is talking to each other through HTTP or HTTPS or something like that. So things will fail. So we need to think about that. We need to think about documenting our APIs. So OpenAPI comes into place. We don't really want to implement all the HTTP calls and to other web services. So REST client comes into place. So there is a lot of things that really you still need, but you don't really want to re-implement every time you create something. Well, config is really, really neat thing to have, and all that, right? So core profile, on top of that, we add all those things. And this is what microprofile brings into the table. But like I said, it could be Spring Boot, it could be a Micronaut, it could be anything else. You'll find similar things there as well. If you don't find the same things as there, then probably you should look for something else, because this is stuff you need for your cloud native applications. There are things on the side that are standalone. We're going to leave them for now. We're not going to talk about them, but they're really nice things that some really nice implementations or specific. This is a specification, but yeah, it's behind it. There is an implementation by different vendors, things like GraphQL and reactive stuff and all the other things.
Not going to mention the standalone part at all in this talk. So if you really want to see how all this works and how it's all placed together, and the cool thing about both microprofile and Jakarta is that it's done by good old ways of annotation. There is a love-hate kind of relationship between developers and annotations. We can hate it or love it or something, but there are different ways of doing that. Different providers, different libraries, different frameworks will help you in different ways, but in this case, it's mostly annotations. And if you really want to have a look on how things work and how things can easily be created using like endpoints, REST endpoints, how you can easily create health and all the other things. There are a bunch of repositories that I've created and shared that you might want to look at. So one of them is very, very simple. It's super basic. You just expose an endpoint that does something very, very simple, picks up two words, a noun and a subject, and no, sorry, adjective and a noun, and then it puts them together, two random words from two sets of words, puts them together and returns it. It was inspired by a two-factor authentication thing that we have back in Norway, where we used to have actually. Now it's been replaced by something else. But we have the same thing. If you've seen random names for Docker, that it keeps on giving you your containers. It's something, usually it's a noun and an adjective. Pretty much the same thing. And there is also a thing of even more advanced example where you add more health metrics and readiness checks and all the other things. On top of that, that's another repository. That's actually another even talk. I just did this talk, the second one, a couple of days ago in Toronto. And yeah, so there are recordings of it, and there is a repository with a lot of documentation and readmes and everything. So if you want to look at that, that's the place to go. Now, we have some code. We kind of agreed on stack, or I decided stack for you, but you can choose and stuff like that. Now that you have a cloud native modernized Java application, and when I call it modern, I really think of it as opposed to the way it used to be back in the days when I started working as a developer. We would just create a jar or a WAR file and put it on Tomcat and just let it run there and don't touch it again. A huge monoliths running inside virtual machines, or even just actual physical machines running some kind of operating system with a Tomcat and that thing on there. This thing is different now, right? We have microservices. We need to make them talk to each other. We need to do some authentication, all this stuff. Now, with all that is fine, but we still need to go serverless. Well, we don't need to, but we would like to go serverless, because to me, it actually means managed list. I told you already. But why do we need to do that? Well, it depends on really usage of how your application is being used. If you're having constant load of users all the time, or quite a lot of users, you probably don't need serverless. It's probably going to be actually more expensive to do that than actually running it on something else. But if your application is not like fully loaded with a lot of users, a lot of load, a lot of requests all the time, you might end up with idling infrastructure, and you don't really want to do that. So because idling infrastructure typically means it will cost you money in one way or another. If it's your servers, well, you'll pay for power, electricity, worst case, or if it is a cloud, you'll end up paying for more because you need to rent CPUs and disks and RAM and all that stuff. There are pros and cons, like I told you. There are, if you have downtime, no, not really downtime. I mean, if your applications are less loaded with requests and all that, that's what I try to call for downtime. Then you might want to save some money on just not using that capacity, freeing that capacity for something else. If it is on-prem, you can use other applications to run that. If it's on cloud, well, you're just not going to pay for that, right? But there are downsides, like I said, because normally the money you pay for CPU and RAM and stuff like that will be a little bit more expensive, or a little bit more as compared to where you rent the same resources constantly over a period of a month or a year or something like that. And also, since serverless means that there is automatic scaling involved in one way or another, on the kind of the most extreme case, it will go scale down to 0 and scale down to infinity, or scale up to infinity when it has to, or anything in between. We still need to think about startup time. Even though we're not scaling down to 0 at all, you will still need to think about startup times. People very, very often forget about that, because when you have one instance and you have a lot of pressure, it needs to scale to, say, 2 or 3 instances. But those 2 or 3 instances will actually still need to boot up. You still need to start them up. And if there is no usage again, it will scale down and scale up and all that. And you need to be able to think about startup times. And also, you need to have actually, or you would like to have some flexibility in the sense of being able to port your applications and portability and vendor lock-in, avoid all that. And also you want to have some control over your containers as well. So it's really, really nice, but again, for a specific use case. If you have a large application, probably it's not your thing. You probably are still good with Kubernetes. What we used to do, I mean, since I started talking about things we used to do, let's say, when I started my first job, so it was like early 2000s, we used to have, I told you, right? We had a physical machine running a Tomcat and monolith on it. The startup times were horrible. The way you fixed that was that you actually went on the website, you kind of did the cold start. It took some time to boot up and everything, but after everything was loaded in the memory, it was fine until you had to reboot. So then we created applications. At some point, we started creating applications with memory leaks because, well, garbage collection does everything for us until it doesn't. So we added some automatic reboots every Sunday or Monday morning, early Monday morning. Then we realized that first users were complaining. So we added a scheduled ping to that endpoint half an hour after it was rebooted automatically. And that's how we fix things, right? We don't want to do that with serverless now. It's not a very good idea. And so we'll see how we can fix that. And there are different ways of doing that. So it's most of the times it's about startup times, but it's also about how fast it is to execute some stuff. So okay, we'll talk. First of all, I want to talk about different runtimes. So for the stack that I've mentioned, we have a lot of choices because remember I told you it's a specification, not an implementation. So implementations do differ, and they actually do make quite a bit of a change on what you're running. So I've been doing quite a bit of experimentation with some of this you see here on the screen and also some other runtimes. And I ended up with quite interesting results because I would get the exact same Java code and Java application with exactly the same Jakarta EE and microprofile stack and all that. Nothing changed except for where it's being run. I've had a difference of first like a cold start response from the cold start request coming in to a response coming back from 1 point something seconds to 25 seconds. I mean, it's not like from 1 to 3 or 5 or something, 25. So just by choosing one of those or choosing something else, you already do something quite a lot actually with your startup times. Another thing that really matters, and it kind of matters, it depends on it really depends on how you run it because or where you run it, because providers and cloud vendors do some smart things. But one of them is image size. So image size does matter to an extent because, well, if your container is super huge, it takes some time to actually stream it over to something else, right? Because that actually brings us to the next point about image lifecycle, because you need to think about what happens if you're running everything serverless. Let's say you're running it on the cloud and it's serverless stack. What happens from the first request coming in to a cold start? So request is coming in to something. That something needs to figure out where to route it. Then it routes this to another thing. I was like, oh yeah, that's for this application. Cool, there. Then it needs to figure out if there are any containers or applications running. If there's none, then it needs to go to container registry or wherever all the containers are stored, find the right container, copy it to wherever it's going to get deployed, initialize everything, and start booting up that container. So it picks up that, right? And then it's there. And at this point, they do some smartness. So sometimes some of the cloud providers start doing things like streaming. So they basically start. If you've looked into containers and seen how they work, it's a bunch of layers, right? So there is a lot of layers. Well, that's how the containers are being defined. That's how you can actually also optimize them when it comes to the build time and all this kind of things. Some of the cloud providers will actually start streaming layer by layer and booting those up so you don't really notice that the containers are too big. But if not, you need to copy the whole container. Then the whole thing needs to start booting. So whatever is parts of operating system on the container is there, needs to boot up. Then whatever platform you're running, like JVM or whatever, needs to boot up. On top of that, your application needs to boot up and load everything to the memory. So there's a lot of things that has happened, right? And then at some point, the whole platform you're running on needs to figure out if the application is up and running and it's ready to receive requests. And that's where the readiness probes come in. So when the readiness probe do say, I'm good, I'm up, then application platform, whatever you're running it on, will actually start serving requests to the application and start serving the replies back when it's done. So there's a lot of things that has to happen, and you really want to have for that to happen for less than a second, because how many of us sitting here or online would be fine with a response time of 25 seconds? No, you'll probably close the whole thing and just go and do something else or go to another website, right? You really want it to be like this, but you still want to for that to happen for a cold start. And that is a bit of a tricky thing. So now you have to think about image sizes, image lifecycle, the whole thing that I told you, the whole kind of the weird circle of life of a container. But then you also have to think about image build time, because if you're doing whatever all the cool kids do, and except for everybody's running on Kubernetes and I have to run on Kubernetes, there are a bunch of other things. It's like, oh, everybody's deploying 100 times a day. So I really need to be able to deploy my little application 100 times a day. Sure. How long does it take to build that? Will you actually be able to do that? Will you be able to provide enough resources to build your application 100 times a day? How much will it cost you in like build minutes or electricity bill or whatever? So you really need to think about a build time as well. And we'll get back to in a few slides, we'll get back to a point where that will be an interesting point. And you need to think about things like time to build new image versus number of deploys versus amount of resources it takes to do that. And of course, I mean, as all good developers do, I did slap on security at the end, at the bottom there. But you know, it's a kind of a bad joke, but we all do that. But we still need to think about that as well. So because all of those containers, even you don't change your code and your code never changes, the new vulnerabilities and things are being found in the libraries that you're using, in the containers that you're running, in the platform that you're using. All that needs to be patched, redeployed, rebuilt, and you cannot just let that container, the same container you built 5 years ago with the legacy code of 15 years ago, and just let it run forever. You still will need to update your containers and patch the whatever security issues that it has, even though code never changes. So that is actually an important thing to think about as well. So a lot of things to think about, right? And when it comes to runtimes, response time and first response time is an interesting thing as well. Most of you probably have heard of Quarkus by now. Quarkus, anyone? Yeah, good. So Red Hat created this a couple of years ago, like super secret project for a while, and then they just like released it all of a sudden, and everybody was talking about it, and for a good reason, because it was really, really nice. The boot times went really crazy. So the gray boxes that you see there would typically be a reference kind of runtime, and time it takes for a cold start, and time it takes for just a simple REST endpoint and some REST point with CRUD. And as you can see, the gray boxes are much bigger compared to the little blue boxes that are actually the Quarkus times. It actually includes both boot and first response time. And what is important to think about here is that we're still running on JVM. So it's still the same JVM. It does a lot of smart things. It does a lot of things on need to know and need to do basis. So it does a lot of things on it does pre-compile a lot of things, and then it uses that to optimize and to do things. But still, we're running on, for now, so here, we're still running on JVM. So there is still optimization happening. So even if it is a little bit slow or whatever that is, the first response times, the next ones can and probably will get better because something inside JVM will optimize something else and it will get better. So that's one thing. The reason I was talking so much about that is that we also have another mode for Quarkus and other runtimes as well. So Helidon is one of them. The other one that will support native images. How many of you know about native images, GraalVM, that kind of stuff? Okay, good. So roughly half of the room. The cool thing is there that it goes really, really fast. Like it's super fast. It's faster than anything else. It's sure. It has smaller footprint because you don't have to load and think about JVM anymore. Everything is just binary. So you compile down all the Java code, all the bytecode, everything into a binary code, and just run it plain. Nothing there. So that also means that there is no JVM. So less footprint, but no optimizations. So if you would see a little kind of a dip of or peak on at a performance getting slower and then kind of going down and getting optimized, with this one you want. It will go faster, but it will never optimize because there is nothing there is nothing that will be able to optimize anything. Another downside is, and I know that there are a few companies that are in Norway and many other places, but like some of our customers as well, they ditched GraalVM images. One of the reasons was that it would take longer time to build them, and if they want to deploy very, very often, they need to sacrifice the kind of the response time to be able to build container images faster and being able to deploy and push them as fast as they can. So a bit longer times, not necessarily very much, but still noticeable if you do it many times, too many times, maybe. And maybe we did have that issue when I was building some demos and stuff. I need a bigger build server to be able to create those images. That problem is almost gone, but it still needs a little bit more resources. It still takes longer time to build container images. And if you're paying, like I said, if you're paying actually per build minutes on your CI/CD pipeline, whatever that is, GitHub Actions, Cloud Build, anything else, Jenkins, whatever. If you're building if you're paying per minute, it will cost you more, but it will be faster. So, pick your battle. Now, I want to talk about something else. Crack. Anyone have heard of crack?
Mhm.
Not that kind of crack, but the
I
other
do not
crack.
know it.
Yes, I know that you do. No? Okay. So, there's an instant on. Anyone? No? Okay. So, Cryo? Linux geeks? Anyone? Okay. Good. Okay, then I have more to talk about. Cool. Crack is where do I start? Okay, let's start with Cryo. So Cryo has been added to Linux kernel long time ago, quite a few years ago. It has given an ability to. So you remember your Windows, I know that both Windows and Macs do that, and it's very seamless now. But back in the days when we used to run things on like Windows XP and stuff, you would get like shutdown, restart, and hibernate. Yeah. So Cryo basically lets you do that with your anything, and it's a part of Linux kernel to hibernate basically. So what it does, it takes everything that's in the memory, dumps it into a disk, and kills the whole thing. And the next time you boot, you just read everything from the disk, and you don't have to think about loading everything to the memory. You just load whatever was there in the memory, and it goes much faster, because that's what I said. Now machines do that seamless, and you don't really notice the difference. But back in the days, it was a big difference from like rebooting your Windows machine to actually hibernating and starting it over again. It was so much faster. So it is a part of Linux kernel, but why are we talking about this now? Well, because it is possible to do the same thing with the containers. And sometimes it's actually very, very nice thing to do that, because every time you start your JVM, your application, all these things I told you, right? Your whatever operating system layer you have needs to start up. JVM has to start. Your application has to start, right? So every time you're doing this whole kind of climbing uphill thing, every time, for every instance, for everything, you just need to keep on doing the same thing. What if we could just take a snapshot at, well, somewhere here, remember it, and every time we need to do something about it, just load that. And then you end up with something that you see on the bottom. So you load once, take a snapshot, remember how it looked. Every time you start a new container, you just start from that point. That goes so much faster. So there is this one is a part of OpenJDK. So it is a part of OpenJDK. It is an OpenJDK project. For now, it's still in an experimental kind of stage. So it needs a specific JDK build. And also there are two flavors of that. So there is one that is this one, and there is a bit more proprietary one by IBM called Instant 9. That's Instant On, sorry. It's part of OpenJ9 and all that thing. But it's called a little bit different, and it works in a slightly different way, but the idea is pretty much the same. You do hibernation kind of way of doing things. The downside is that it's part of Linux kernel, so it only works on Linux, but nobody cares because all the containers are on Linux, most of them anyway. What the cool thing with Crack, that if I remember it correctly, unless they have changed it very recently. Instant on does not do that. It actually lets you create checkpoints, those checkpoints, and dump the whole thing to a disk using both API, so like a code call and a command line. So that part is also cool. So you can create an application, start up an application, call a hibernation or checkpoint, dump everything, store it somewhere else outside your container, and next time from there on, you can actually build a new container with that little file in it. And next time you will start a container, it will just read from that file. So that can be a part of your CI/CD pipeline now all of a sudden. And when you do that, it will go faster. It is a bit in experimental mode for now. And when I was playing around and preparing for this talk, I did end up with finding a few things. And so I ended up talking quite a bit to the engineering team there as well. And I was told at some point, they were like, I was like, no, it's not working. These options are not working. And this thing something is wrong. And there was like, they were like, no, you're doing something wrong. You're doing something wrong. And I was like, no, I don't. I'm pretty sure. Look, try it. And then like it gets quiet for a second. And then they ping me again. It's like, well, we need to build a new JDK for you. So it was actually a little bug there. But I mean, it's really, really nice. It was like really cool working with the team and, all these things and playing around and testing things. I think there was something about, I don't remember exactly. I think it was something about the M2 Max, because I was building on this one. So they tested it on Intel, but not on AMD and ARM and all this kind of stuff. So something. Doesn't matter. But the point is that it still needs to need some more work to make it work out of the box. And there is another thing, is that it's still only contents of your memory. But if your frameworks or runtimes or whatever you're running, you're using inside your application, create connections, things like database connections or WebSockets or whatever, that is not part. I mean, it's in the memory, it's just an address to a connection, right? It's not, the connection does not exist in the memory per se, it's on the network level and all that. You need to create those every time you restore. So you create a checkpoint, you dump everything, but you need to remember what to restore. So next time you're actually starting up, you load from things from memory, and then you restore your connections. You really need to do that. Most of the frameworks and stuff, like things like Spring Boot and Micronaut and all the other ones, they did implement their own handling of all that. So you don't have to think about it. You just create checkpoint, you restore, everything magically happens. Some of them, they don't, and then you really need to be careful. All right? Confusing enough? Good. Good. Okay. I did create a few examples to show you. I mean, I can show you live as well, but there are some parts of a repository that I've shown you already that explain different things and different parts of this. So part of changing runtime is really kind of really cool, because how much time do I have? Yeah, I mean, we're almost out of time, but or 5 minutes, 10 minutes? Yeah. Okay, I'll talk through this for now, and then I'll show you some code if you want. But then local builds and runs. To change a runtime, you can just change a POM file, because remember I told you it's all specifications. It's up to the providers and vendors to implement it. That also means that you can change things in your POM file, and you switch from, say, I don't know, Quarkus to Helidon, from Helidon to OpenLiberty, from OpenLiberty to Tom EE or whatever. It's all just POM files. Or if you want to go Gradle and stuff, that's, well, You're on your, no, well, yeah. No, I'm not-
Editorial comment. yes.
I'm not gonna be, I'm not gonna say that. But I mean, you can do that as well. I mean, it's like I say POM files because I'm kind of a bit too too grown, too close to Maven, I guess. I don't know. Too big fan, whatever. You know what I mean. But again, you don't have to change your code. You can just switch config and it will just switch to another provider. And I actually do show that. Let's see if I can, yeah, this works. Nice. Yeah, surprising. Okay, cool. It was like I was actually sharing a whole window. That's good. Yeah. So what you see here, you can actually see how you just basically specify, instead of just saying Maven clean package, not deploy, package, as another pet peeve of some of us. But here you can actually specify a POM file, a specific file. So, because otherwise it will just go for POM XML, but here you can say POM Liberty, POM Quarkus, POM Helidon, whatever, and that's all. So like you just do that, and those POM files are the only things that are different, and they're in here, right? POM Liberty, POM Helidon, POM Quarkus. I did create a POM XML. I think this is a copy of Quarkus, if I remember that correctly, but it will still run. You know, you just need to do Java jar, blah, 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 and then it will be just there. So that's really cool. You can switch the runtimes like this. What else? Full screen. Another thing is, oh yeah, building Graalvm native images. So, like I said, it needs to be a little bit different. So you have to use a different POM file, and you need to be able to provide more resources if that thing needs that. I had to do that back in the days, and like a few months back, but at some point it stopped requesting too much resources, which was really, really nice. And again, it's the same thing. So if you want to go with native images and all that, you can have a look at my build file. So what I did here, as all engineers do, I ended up over-engineering the whole everything. So I created a parameterized build file. So this looks like many other pipelines that you've seen, GitHub Actions, all the other things. So this is from Cloud Build, but it's very similar syntax for many other tools like that, because we're all big fans of YAML or not. I'm not sure which part, but we're not going to talk about that. But what I did was I introduced a bunch of variables here. So you'll have all these things with $ something something. It's a variable, and I do have a default versions here. If it's not provided, it's that, and if I do provide it, it changes that. But the cool thing is that you can actually see you can actually use you can actually build your own containers using providing different what I call for flavors. So I just called flavor JVM or flavor native. But all in all, what it actually does in the background, it is basically switching Docker files, because I have a Docker file for Crack, I have a Docker file for JVM, and I have a Docker file for native. See, native, JVM, Crack. So what I do is basically I just create Docker build with different files. A kind of a side note, but if you really are into optimizing your build times and you really want to look into how like layers and things work and you're using Maven. The downside of Maven, it downloads internet at least twice every time you build things. And if you build it in a container, it's a bit kind of sucks because you will definitely download internet once or twice or something. For even a tiny little change. Every time you build it, it will change because, you know, layers and things change on the layer level and a file system and all that. The way you do that to solve that, you can actually cheat a little bit and you can force it to first download everything. And then, because you see, I'm doing a dry run. Where is it? Yeah, here we go. So first I do run Maven here, and I say go offline for dependencies. So I just like download everything. I don't change and don't touch everything. I just keep all those dependencies there. Then I actually copy my own source code that will change more often. And then I do actually a proper build. And by doing that, I don't have to build and download every dependency every time and everything. And the other cool thing here, I'm actually using multi-stage builds. So I do first stage where I build everything, then I throw it away. I keep just artifacts and actually create the container that I really need. So you're minimizing size of that as well. But, you know, this is not part of this talk really, but it's still part of optimization of your builds. Pipelines as well. So it's kind of a cool thing. People really tend to forget about all that. Believe me, I've seen that lots of times. And well, Crack is still a bit working and sometimes it's a bit, sometimes it breaks. So right now I think it might break if you use my code that is in the repository for Crack, but I'll get it fixed when I'm back from my vacation at some point. I mean, my vacation is almost over. I'm flying back home tomorrow. So, soon-ish. That's famous last words, right? Some final thoughts. Well, running Java on cloud is definitely possible, and you should do that. It's not a privilege of any other languages. It really works really well and really nicely. You do need to think about a few things, and that really goes with any language, any platform, any library, or anything else. But I keep seeing people forgetting about that. So I'm going to mention it again. First, runtime, right? Startup times, they do differ. Runtime footprint does differ. And support for whatever you want to use. You want to use Jakarta EE, Micronaut, Spring Boot, micro profile, you know, all those things. You need to check that whatever you want to choose as a runtime actually supports that. And a kind of a side note there, I do remember we had I do remember that we had a Docker Compose file, which contained Quarkus image and a bunch of others like Open Liberty and Tomi, whatever, like Pyara or something else. There was basically a bunch of others, and there was Quarkus. And Docker Compose basically boots all the containers, starts booting all at the same time, and they all start logging into the same terminal. By the time any other container, anything, I'm not really putting anyone out there on the spot, anything started even logging that they're about to think about starting up, Quarkus was already done. So, you know, that thing is quite fast, and it would be just like, oh, done booting, ready to request application calls, like HTTP requests. And the other one's like, oh, I'm starting my containers. Let me think and see what happens. And, you know, blah, 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 blah. 5 seconds, 10 seconds later, they would say the same thing. So they do runtimes, they do differ. I do have some timings as well. I did take, actually, I can show you that in a second. And then you need to think about where to deploy. Do you need a VM? Do you need a virtual machine? Do you really need a virtual machine? Can you avoid that? do you really, I mean, I do not understand that all the kids, cool kids are using Kubernetes, but do you really need that? Maybe not. Can you go serverless? Can you go serverless as a full-fledged container application, or can you go serverless as a tiny little serverless function? Think about that. There is no right and wrong answer. It will depend on your application. And then you need to optimize. So optimization comes to startup times. Startup times for your container, startup time for your JVM or not JVM or whatever, but also startup time for your application. You need to optimize your application as well, because if you're loading everything into a memory and it takes like gigabytes of memory to load on that, it will still be slow. You need to optimize all these three things. Container size obviously matters because it has to be copied and thrown around over the network quite a few times. And build time and resources, that also is an important part because that costs money. That costs minutes, right? Build minutes and all this kind of things. Right. So this is it of the presentation, but I'll show you some startup times. I think I still have application running, and that will be fun. I am on social medias on all kinds, and I got tired of listing them all on the website, so I created that website where you can go in there and you'll find all the like Twitter and Blue Sky and Mastodon and anything else that is supposed to take over at this point. So that's where you can find me. And let's see, IntelliJ. Let me find another project. Oh, that won't take long, I promise. New window. So there is a. Oh, you can see that. Good.
That's good.
Yeah, I mean, I don't have to show you all the steps. Let's see. Screen. Yeah, I can do screen. Share. Yep, there you go. And then I'll do another thing. I'll increase the zoom in a little bit. Yeah, better. Okay, so this is actual container images, sizes of containers just by changing runtime. And this is response times. Like the response times do vary a bit. So it's not going to be exact numbers every time, but this is like a ballpark. And you can see, so we're going from like anywhere around 20 something seconds to 2 something seconds. That is just for JVM mode. And then we have things like native as well. So what we can do is we can actually do, so this is my cheat sheet. I created, so I did build and deploy different applications. You see, it's like Focus JVM, Crocus Native, Helidon JVM, Helidon Native, Open Liberty JVM. So, and I created separate applications, deploy them all on CloudRun, on the same cloud and same code, same everything. And I do time a curl call, right? And I've been on vacation. I haven't used that for a while, for a long time. So they all have been scaled down to 0. We'll have cold starts. Okay. See what happens. There you go. 7 seconds, 2 seconds. So you see, that was the JVM version and GraalVM version. 6 seconds and 2 seconds, 6.7 and 1.9. That's for a JVM Helidon and GraalVM Helidon. And the last one will take some time. I don't know why. I really need to talk to some people on the team and to figure out why. But it's, see, 25 seconds, 24 and a half. So,
On Open Liberty, there's an XML file, or actually, I think there's a.
Yep.
And you can take out the things that you don't need in your
Sure.
application, and it'll go, I mean, it can load in 3 seconds if you take everything out.
that's right. Yeah, so there is a file where you can actually take them out, and I think there are other providers also have something similar, and I did do some of it, but for me it was like I wanted to be as out of the box as possible, right? And so yes, and the other thing you can do here to make it to optimize it, and you can throw in instant on, which is basically crack, the one that the thing I talked about, and that will also go faster. But I mean, that's all next step. I want to just go like out of the box as a typical basic user or like simple user of an application would be. So see, it's the same infrastructure, same everything, same absolutely everything, but such a big difference. And the cool thing is that, I mean, last thing I want to show, which is kind of obvious, but I'm going to show it anyway, is that now we've already run all that, right? So now it's not cold start. So you can see how fast that goes. And it's pretty much the same. See, now we're down to 0.23. Yeah, well, I mean, almost the same, right? It's just still milliseconds difference. So not cold starts, they're not that bad. I mean, that's pretty cool. While cold starts really make a difference, and cold starts will again make a difference when you scale things up and down. It's not only just when it goes down to 0. Right. Any questions, comments, thoughts, anything?
Question.
I haven't seen that time command before.
Oh,
Is that
it's
something,
been there for a while.
has it?
Yeah.
Okay.
It's really nice. It's really neat. You can time anything. I used to time. I think I used I used to do that for running SQL scripts into horrible, huge PL/SQL scripts into database to time them. That was really nice.
Are you running that on a Mac or on Linux?
Which one? The time thing?
Time.
No, this is on this machine. So this is on a Mac. But the thing is that
Same.
yeah, it's the same, and also like the where did they? Oh, there it is. So the time command itself is on a Mac, but the URLs and everything is out in the cloud. So it's nothing running on this machine for this thing. But technically I just could have just run Docker on this and just run the same containers here as well.
And staged builds, I haven't,
Multi-stage builds?
Multi-stage
yeah, those
builds.
are really nice because like I said, you're building. Where did it go? Let's do Docker. See, it's like it's work in progress. I have a bunch of files that are not committed and stuff. But it's really nice because you create your stuff, and at this point, so you give it a name. I gave it a name Maven, right? Here. And when I take that name, I can use that later. So I can say from Maven, and then I tell it where to find it. So it basically works like a regular copy, like, source and destination. So I say from Maven, that's like from the previous container, copy it to this container into this what do you call that, path. And that's it. And then at some point when I'm done doing that, it will throw away the previous containers. It's really nice. It's because otherwise I would have a lot of garbage from Maven inside my container, and I really don't want that. So, but yeah, so the most weird thing probably is I do here, which is a bit like, this Maven run verify. Never fail. That is a trick, like I said, for the layering. So technically I run Maven verify twice, or Maven package, or whatever stage I want to go for. But that saves me a lot of a lot of trouble later, so I don't have to spend time rebuilding and downloading everything over again if I just change a tiny little thing in a code. And there is one more thing. What was that? There was something. Oh yeah. If you're running all that locally and you really want to restart and you're running on Quarkus, there is also something called remote. Let's see. Shameless plug. I did blog about this thing tiny little bit earlier. So yeah, there is something called a remote development session. So you can actually in Quarkus. So if you want to do it, so you have a bunch of containers running and say Docker Compose, but you don't really want to redeploy a specific container in this Docker Compose thing on your machine. You can create a simultaneous remote development sessions to those different containers, and Quarkus will rebuild and change the code and recompile everything live every time you press the save button. So that's really, really nice. So you don't have to think about building a new image every time when you're developing things locally. But that's mostly useful for local development, but technically can be used also for development out there in a cloud or whatever VM. But that's probably not so very good idea to do just without proper planning, because that's a security hole, gaping hole that you're opening up, because it ends up in it creates an endpoint that will receive a zip file of all the changed files and deploy them automatically. But the reason I had to blog about that is that it works really well for one container, but if you use several containers, you need to change port numbers. Otherwise, it just kind of gets very confused.
Other questions, comments, thoughts, conclusions? I think we're done then. Thank you so much. That was
Thank you.
really. I'm going to come over here and wrap up the old meeting. Rustam, that was wonderful.
Thank you.
Well, people always say that at the end of a talk, right? I mean it this time. I absolutely do. That's fascinating. I think we'll watch that again. It's on YouTube. And hello to our YouTube visitors. Join us next time, September 10th, 2024, when our guest will be Marcus Hellberg. He'll be talking about, I'm reading this because I don't want to get it wrong, building a custom AI chatbot with Spring Boot, React, and LongChain 4J. Hope to see you then. Thank you so much for coming tonight. And once again, thank you, Rustam.
Thank you for having me.
Did I say what? LongChain?
Same.
Did I say LongChain?
You said long.
Let me come back. LangChain.